Okay, here we go. Okay. All right. Hi, everyone. So, for those of you who don't know me, I am Miss Who, your physics teacher. Right. So, what we're going to be doing in this video is we will be looking at how to calculate the gradient of a graph, specifically the graph for the simple pendulum experiment. And thereafter, we're going to learn how to relate the value of this gradient to the formula that's provided, which is t squared equals 4 pi squared L over G. All right. So, I know this Jamboard is blank. Hold on. I'm going to be throwing stuff on it. Okay. So of course, going to this video, this is assuming that you already have your graph all completed and drawn and prepared. That means you've got your axes drawn, you've got the plots done, and you've already drawn the best fit line, no hanging graphs, remember? Okay, so now whether your graph is directly proportional or it's just a linear graph, it doesn't matter. The absolutely correct graph, of course, is a directly proportional graph. But if your data doesn't allow you to get that and you end up getting a linear graph. Let me just show you what I mean, right? Okay. Whoops. Sorry, I did that wrong. Okay. So I'm just going to change color just for sure. So ideally, your graph that's plotted should be a linear graph that goes through origin, which means it's a relationship that's directly proportional. But let's say you've already plotted, you've got all your coordinates plotted out, and you find you cannot get a directly proportional graph. You know, it's fudging the data too much. So fudging here just means that you have to change the data or change the appearance a little bit. Hold on, that was not a straight line. So if you end up getting a graph that's linear instead, um, if that's what your data shows, that's what your data shows, and that's just how it is. Don't force the data to be something that it's not. So if it's a linear graph that does not go through origin, that's fine. Just follow what your data presents. Let's say, for example, you get a graph like this. You know what? That's okay. Just work with it. That's fine. Even if it goes through the x-axis instead, that's fine. Just work with it. Okay. So in this video, I'm just going to show for in both cases, whether it's directly proportional or if it goes through, or if it touches the axis instead, how do we calculate the gradient? So let's recall how to calculate gradient. All right. So gradient, let me just create another slide here just for scribbles. We know that the gradient calculation, did I just write y? Sorry, it's late. I'm tired. So if you want to calculate gradient, which is usually represented with symbol m, right? It's y2 minus y1 over x2 minus x1. Now, I know that many students, they just know how to use the formula, but they actually have no idea what they're calculating. So if you look at this, right, y2 minus y1 is actually the difference in y. So, like you have two coordinates, right? Let's say if I just randomly draw a graph here, you've got two coordinates here. Let's say this is x2, y2, and this is x1, y1. Basically, y2 minus y1 is the difference between these two y's. And x2 minus x1 is the difference between these two x. So sometimes we write it this way, the change in y over change in x, or difference in y or difference in x. Some students learn it as rise over run, which is quite cute and fun, and I think that it works perfectly fine as well. Rise over run. All right. So what exactly is a gradient? Gradient is actually the calculation that shows how steep the graph is. So the greater the steepness, then the greater the value of the gradient, right? The lower the steepness, the lower the value of the gradient. So typically when you calculate gradient from a graph, you must show how you get the gradient. Now, how you show it is not by labeling the coordinate. No. What you do is you got to draw the gradient triangle out, because, okay, from here you draw two lines parallel to the x-axis and the y-axis, dotted line. Okay. By the way, in case you're wondering when it should be dotted and when it shouldn't be, if it's part of the graph, it's a solid line. If it's an imaginary line or a guideline, dotted line. So for example, what I've just drawn here, this is known as the gradient triangle. The gradient triangle, because it's a guideline. We create this triangle so that we can calculate the gradient. You draw this as dotted. Okay, so I know got a lot of extra bits here, no need lah ha, okay, but you should draw the gradient triangle. So if you look at the gradient triangle, you can see this line, which is parallel to the y-axis, this is showing us the difference in y, and this line, which is parallel to the x-axis, that's showing us the difference in x. This is the rise, this is the run. So the gradient is actually the ratio of the difference in y to difference in x. So for example, if we have a graph that is steeper, you will find that, just draw the gradient triangle first, all right? And you'll find here, you'll see this y is of a higher ratio, like the length of y is greater than the x. The ratio of this y to this x is greater than this ratio of this y to this x. And that's why this has a greater slope. All right. So that's the idea of the gradient, right? It's a comparison of the slope. And by drawing out the gradient triangle, and normally we have to indicate with the right angle triangle, right? The purpose of drawing a gradient triangle is to clearly show the ratio. Let me move my face so I can get to this. To get this ratio, let me rephrase. Is to get the ratio of this y to this x. So it's a visual comparison of this ratio. That's the purpose of drawing a gradient triangle. So whenever you calculate a gradient and the question tells you, show how you get the gradient on the graph, you draw the gradient triangle. This is how you show it. Okay. The question won't tell you, draw the gradient triangle. It won't tell you because you are expected to know about this gradient triangle. Okay. So just labeling coordinates, and some students do that. They label the coordinates, da, 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 there, I put the coordinates in here. No, that's just labeling coordinates. That's not showing us anything. Gradient triangle is how you show how we calculate the gradient. So I'm just going to backtrack to slide number 1. Now, when you want to draw the gradient triangle, don't be lazy. All right, in physics, please remember, in physics, size matters. The bigger, the better. So just like how when we plot the graph on our graph paper, you've got to get the size of the graph as big as possible. So the gradient triangle should also be as big as possible. So don't do this. Where you're like, okay lah, I know like in maths, all right, linear graph, any 2 points you take, gradient is the same. So never mind lah, teacher, I tell you what, I take these 2 points, ta-da, can already. Cannot. Okay, no, let me do the GSE way. Hello, cannot. You cannot be taking such a tiny gradient triangle and expect that to work. You must understand that when it comes to physics, you cannot. The reason for this is because, you see, the line that you've drawn is a best fit line. Your data is probably scattered. You will not get perfect 5. Okay, cannot. If you get this, actually, they mark you wrong. This is like cheating really, because impossible to get perfect data. So in reality, what is likely is that your data is scattered. Okay, so may not be exactly like this, but it is still kind of scattered. Okay, so if it's scattered, what happens is, if you want to calculate the gradient, it's you cannot take it from such a small point because it's merely an estimate. It's the best fit line. In order to get a more accurate value, your gradient triangle must be as big as possible, because the larger the line, the clearer the bigger the space is between all those coordinates. And you'll find that you have to you have to get 2 points that are as far away from each other as possible to have a more accurate reading. So the gradient triangle cannot be this tiny little thing over here. Okay, so how to get the correct gradient triangle? Try to take 2 points that are as far away from each other as possible, which means that ideally you should take this point and this point. But let's say you've plotted and you find, but teacher, this point is at a rather awkward position. I can't read the readings clearly. okay lah, then don't take that point. What you do is you find like the highest point possible where you can get a very nice clear reading on both sides. So if it's slightly lower, that's fine. It still works. Then you plot your gradient triangle. Okay, one line parallel to the y-axis, one line parallel to the x-axis. Now, if you find that, oh, but sure, cannot see my line is on the x-axis. Never mind, just do it anyway. Just do the dottedness. So which means you should draw a dotted. Okay, and then draw the right angle symbol over there to let the examiner know, oh, okay, this line is part of the gradient triangle like this. Okay, if you want to emphasize it even more, you can even add this symbol. Well, not symbols, labels. Okay, you can. So this is just to emphasize in case you think the examiner half blind, can't see where your gradient triangle is. Hello, it's here, sir or ma'am. Okay, it's right here. So you can. Okay, if you want to indicate. So the same thing also for this kind of graph. Again, take the 2 points that are furthest away from each other as possible. So one could be right on the y-axis, or if you're on the x-axis, if your line is this side, right? And then over here if you can. If you find this point is rather awkward, remember you don't have to take that point. Take the next highest point where you can take the reading from the L-axis and the t-squared axis easily. So if it's slightly lower, that's fine. And so your gradient triangle would be somewhere here. So one line parallel to the x-axis, one line parallel to the y-axis, dotted. So, okay, dotted, dot. And in case you are worried the examiner already and then the glasses so thick can't see where your gradient triangle is, then you label, all right? Y2 minus y1, x2 minus x1 together with the right angle symbol. Okay, so this is how you show on the graph how you obtain the gradient triangle. All right, and then what you should do is then you calculate your gradient. Right now, the calculation of the gradient. By the way, for those of you who are working on the experiment reports, please write the gradient calculation in your report and not on the graph. Okay, not on the graph paper, in the report. But anyway, for the purpose of this lesson, I'm just going to write, okay, the formula as we already know is y2 minus y1 over x2 minus x1, and you calculate from there. Okay. Now, when you write out your final number, after you've calculated it, right, you must also write the unit. If you're like, huh? Gradient has unit? Yes, it does. Physics, almost everything has units. The only things that don't have units is because the units cancel each other out. And we will cover that in a later chapter. But for this one, yes, got unit. How to figure out the unit? Okay, it's not difficult. You see, remember that, let me move my face again because I want to get to this pointer. You see, gradient calculation is just what? Y over X. So but in this case though, okay, we don't call this y or x. Y-axis, x-axis, yes, but you see this is not y, this is what? T squared. This is actually what? L. And you see your y-axis a got unit, x-axis also got unit. What are the units? I'm going to change color just because. Okay, so y, which is t squared, the unit is second squared. And then the x, what's the unit? cm. That means the unit for the gradient is second squared per cm. Now it's okay if you're like, teacher, I've never heard of this. Never mind. Just there will be plenty of units you have never heard of before. The combination is very weird. You have to learn how to work with it. Okay, so don't panic. So whatever calculation you get, so I'm not putting any numbers here because of course you guys have to put in your own numbers. But let's say you do the calculation, whatever you count lah. Okay, I'm just putting dot here means you put in your numbers, alright? You count, and then your final answer, whatever it is, your number here, with the unit second squared per cm. Okay, so this goes into your experiment report under the analysis section. Don't write this on the graph. Okay, so this is how you calculate the gradient and together with the unit, and this is and how you show the gradient, how you obtain the gradient from your respective graphs. Okay. Next, let's talk about that formula, which I know you like. I teacher, I've never seen it before in my life. It's okay, just work with it. Now, so this formula, of course, was derived. The simple pendulum experiment. They've done this and they figured out, okay, this is the equation that relates the period of the simple pendulum to its length. So what we're going to do is we're going to learn how to relate this equation to our graphs. So I'm going to write that out now. T squared equals to 4 pi squared L over G. Okay, so how do we relate this graph to how do we relate this equation to our graph? Now, if you have learned linear law in at maths, then you would know how to relate this formula to your graph. If you haven't learned it yet, never mind. All right, I'll explain how this works. So I'm just going to do a simple sketch here just because, it's too, let me put it a bit smaller, not to be so big. Okay, so let's say this is our graph, which we plotted t squared against L. All right. Of course, the unit. Let me just scribble the unit here. Okay. Now, if you look, right, this is actually what t squared on our y-axis, L is on our x-axis. And let's look back at our gradient calculation. M is, I'm going to write it this way, the change in y or over the change in x. Now, what is on our y-axis? T squared. What is on our x-axis? L. Can you see that the gradient is actually equal to t squared over L? So what we're going to do with this equation and how we relate it is we're going to rewrite this equation into this form. That means on the left-hand side, we're going to try to get t squared over L. So you see over here, the left side, we already have t squared. L is on the right-hand side. So what we're going to do is we're going to move my face out of the way so I can get here. Okay, so what we're going to do is we're going to take L and move it down here so that we can get t squared over L. So this gives us t squared over L on the left hand side. And then what's left? What is remaining? Left and right, right? Well, what's remaining on the right hand side? We have 4 pi squared over G. So how does this work then? And what do? We have our gradient ready, right? And we know our gradient is equal to t squared over L. And from this complicated equation, we can see that t squared over L equals to 4 pi squared over G. So when we marry the two, these two combine together, what do we get? Let me put it here. What we will get is M equals 4 pi squared over G. Okay, I realize the arrow is a bit chacat. So I'm just going to fix the arrow because it looks like I sesat a bit. Okay, so let me do that again. Okay, so this one we combine to here and this one we combine to here. Combine together like that, see, right? Okay, so what's the purpose of this? The purpose of this is so that we can calculate the value of G. Okay, I got something excited just now. All right, so how we calculate it? So if we look at what you have counted, you've already calculated the value of M, right? In the, in just now the slide one that we saw. So how you calculate the value of G is then you swap this position, right? G becomes equal to 4 pi squared over M. All right, so what you do is you take your value of M and you put it into this equation and you calculate out your value of G. Let me show you an example. Let's say, for example, please, this is my example. You use your number, okay? Okay, don't be take teacher's number and put the number, then use your number, okay? Let's say, for example, my graph, I count my gradient already. Let's say my gradient I got the value of 0.04 seconds squared per cm. Then, okay, I need to calculate the value of G, right? So from slide number 3, already count. We know, we derive already and work it out. Oh, G equals 4 pi squared over M. So G equals 4 pi squared over M. So what we'll do is we'll take this value and put it in. So equals to 4 pi squared over 0.04. So I'm just going to pull out my calculator and work it out. So camera's off screen, okay? I'm using my laptop putting a calculator, okay? And my mouse is not behaving now. Where's my mouse? Okay, there we go. Okay, it's really not behaving. Okay, times pi squared, and then we divide it by 0.04, and the number I get is 986.96. So remember, in SPM physics, we should always write up to 2 to 3 decimal places, right? So 986.96 unit. Okay, so this is how you work out the unit. Okay, you see, right? From this equation, 4 is a constant, there's no unit. Pi is also a constant, no unit. M got unit or not? Got. M is in seconds squared per cm. But it's under the fraction, right? And so what happens is, because it's the inverse, okay, it's the inverse of this, which means this will become second to the power negative 2, and cm from negative 1 becomes positive 1. But you can't write it this way, right? It should be always the positive numbers in front. So cm per second squared, which means that the the value of g is cm per second squared. Ta-da! And that's how you get your number. So if any of you happen to get number that's not exactly like this, it's fine. The usual values we get that I've seen in past years are always between 800 to about 1100. Even if your number is slightly more or less than that, that's fine. Okay, just calculate whatever number you get. Okay, that's what you write lah in your report. Okay, so if let's look back again just to recap. Okay, so remember that in order to calculate your gradient, you need to use a formula of y2 minus y1 over x2 minus x1, right? And you need to show how you obtain the gradient from your graph. So draw the gradient triangle out. The gradient triangle should be as large as possible. Pick 2 points that are as far away from each other as possible. And when you work out the values, you must write the unit, and this is how you figure out the unit. Based on the gradient that has been obtained, right? We need to compare this or rather relate it to this equation. So what we do is we look at the graph and we see, oh, okay, the gradient is actually what? T squared over L. And then we rewrite this equation, making the subject T squared over L. And then we find that we can combine these two so that you get M equals 4 pi squared over G. Rewrite so that G equals 4 pi squared over M, and then substitute the value of M in, and ta-da, you get the value of G based on your experiment. And that's it. Easy, right? Okay, it's not that easy, but I hope you understand what we have covered so far. I hope you found this video educational and helpful. So, shameless plug, please don't forget to click like and subscribe for more videos just like this from your favorite physics teacher. Okay, see you soon.